Hi, welcome back. So today we're going to talk about the table. Um, so we have started doing the listing up to now. So we are in this video we're going to do the table one. Okay. So before we continue with the programming in the Python, so let's continue checking that what is the mock shell looks like. So this is the mock shell. So it has a safety population. So this is the title of the mock shell of the table is subject assignment to analysis population. Okay. So here what we're doing here, so here we are trying to make it like percentages for the n counts. So we need to calculate the how many subjects have safety population, and how many subjects undergoes ITT population, and how many subjects are in randomization population. So all of them are already assigned the what are the variables has to be taken for um, these three populations. Okay, so here we have a safety population, then intended treatment population, then randomization flag. Okay, so we have three drugs here. So drug A, drug B, sorry, two drugs, and this is the combined ones. So after drug A and drug B both combined, and we have to calculate how many population, how many subjects are in the safety population. So how many subjects are taking the treatment. So and we have to calculate the percentage for in each individual population. Okay. So this is a simple mock shell. Let's continue with the programming in the Python. Okay. Okay, so let's start with resetting the if there any is clear to just make it clear for the previous any outputs are currently working. So we try to reset them by using the percentage reset hyphen f. Then we start logging all this information into one table one log.txt. Okay, so before we have to stop it the log, then we start with a fresh table one dot log. So let me run this one. Okay, so here what I'm using Python 3.13.4 version kernel. So that is the one I'm using here. So now we have to import the libraries. So the most important one we should need for this report is docx. Okay, so I need that part. So and I'm also applying the Atom path because I need to import the Atom datasets in order to execute this program, this mock shell to this reporting. Okay, and here what I'm doing, I'm just using the class and object. So here what I'm doing, I'm just trying to read the SAS7 BDAT because Atom dataset is in the SAS7 BDAT. So we need to import into this reporting programming. So for that we need one class objects. Okay, by using the OS list directory. So that is the package we have used, and also we have a pirate stat. Here is another package we are using mostly for to read the SAS7 BDAT. So this is the package. Okay, then we have to import by using this class objects Atom dataset and get function. We to import the ADSL. So I'm naming that ADSL as ADSL. If you want to check the data, you go here and check the analysis datasets like ADSL dataset. Okay, so here we'll be having almost like 116 to 55 columns. Okay, so here we have all the related to information of the treatment. Okay, and the population flags. After that one, what I'm doing, I'm just trying to filter here by using TRT01A not should not have any NAs, and also TRT01A should not have any missing values. So that is I keep it as a ADSL filter. Then ADSL filter I'm making as a set for the new data set name, data frame name, ADSL all. So then what I'm doing, ADSL all, I'm TRT01A, I'm creating a extra TRT01A equal to all new variable. Is not new variable, I'm just creating all to make it like overall count. Then I'm using trtan as a for the numeric part. So I'm doing this through, I'm assigning these three as an extra. Then what I'm doing, I'm just combining with ADSL filter and this one and this one, and we will be get ADSL combined will be having along with the TRT01A we will be having all and the three in the numeric format. Okay, and ignore index 2. That means if there is concatenation, we are trying to reset the sequence of the records. Then and denominator ADSL combined for this part, and group by, we are grouping by and TRT01A TRT01A because we want to calculate the counts. Okay, by unit subject ID, and we are selecting we are selecting the unique elements of this unique subject id. Okay, then we are resetting the index name denominator. So we are reset the index, then we're giving as a name as a denom. So then end dictionary denom dot set index, we are giving as a set index for trt01a and denom. So this is a denom function. So we are in the trt01a denom to dictionaries. Okay. Okay, so here we have to dictionary, we are creating the dictionary. Then what we're doing with this dictionary, and we get the counts for n1, and if it is default then we give it as a 0. If there is missing, we give it as a 0. So here for get 1 for the n1, and get 2 will be the n2, and get 3 will be the n3. So the n3, n1, n2, if I run this one, I can show you what is that mean. So if you go to check the Jupyters, and if you go ADSL combine, okay, so here we will be having maybe we go to ADSL combined, so you'll be having all the, okay, TRT01A. So here we'll be having only TRT01A. So now you see here we'll be having the 25% will be tafenoquine and placebo will be 25%, and all will be having 50% because we are combining these two medications, these two drugs into overall. So that is the part, and here also you can see the actual parts. You will be seeing that counts 86 here, and the counts will be 43, and the 43 here, 43, 43 and 86, that is for the all, and this is for the placebo, and this is for the tefenoquine. Okay, so we can able to see that part here. Then if I check n1, n2, n3, so if I go in dictionary here, so you'll be seeing that the first one will be having 43 code for 43, then all will be the 83 or 86, sorry, 86. These are the counts for the drug A and drug B. So drug A will be considered as a tefenoquine, and drug B will be the placebo here. So next what we're doing, the population, we are calculating the population count. So here we are creating a one function. So we'll be having the flag variable label order in that functions. This works like a positional on 3. Then after that we will be using this ADSL combined data set, then ADSL combined and flag var, we're keeping the flag var equal to y. Then grouped by data frame group by, we are grouping by the TRT treatment by unique subject in the unique combination of the unique subject ID. Then we are resetting the sequence, then we give as a pop as a label, population as a label, then order will be giving as a order returned grouped. So this is the function we are using, and we're going to use the same function here in order to execute. So here the summary pd concat, so we are concatenating these all these four populations. So here in the mock shell, so we'll be having only 3 populations, but we'll be having another population, that is per protocol populations. Make sure there should not be any missing protocol information for that population. Okay, so here we the safety population flag, intent to treatment population flag, randomization flag, per protocol flag, these 4 are populations flag in the ADSL. So we are considering here as a variables, and here we'll be having the labels. So you can see exactly the flag var is this one, the flag variables, and label, so label will be having these ones, and then we give it as an order. Okay, so flag var equal to y, we are considering filtering out. So we do all these three, instead of writing multiple times, we do right away everything here by creating one function. Okay, so here what so we once we done a group by, so once we done, then what we're doing, the summary equal to summary dot merge, and the denom, so we are merging with the denom and by TRT01 and TRT0. So the denom will be this part, the denom. So if we check the denom part, let me show you the denom part here, how it looks. So denom you will be see here will be having TRT01A and the TRT01A in the actual in the numeric format, and we'll be having the denom will be the counts. So we are considering that counts, and on TRT01 TR and left join, we are merging with the left join. Then summary group, so this part equal to, so grp sum apply lambda row for concatenate unique subject id, and unique subject id divided by denom into 100. So what we are doing, we're trying to do with the counts along with the percentage of the denom, like the unique subject how many counts divided by the denom into 100%. So we are calculating here for this part, so percentage part. So here we will be having this part. Okay, so that is the one. So okay, so here what we're doing here, because we are trying taking the each unique subject ID, and considering and dividing by the denominator into 100, and we are giving as a one formatted decimal, because as per the Mockshell it is having only 1 point of the decimal. Okay, and axis 1 will be because we are considering for each individual row, and we are creating the new column called GRP. So if I click this one and if I go check for the GRP here, sorry, summary, I have to check the summary data frame. So now you see here, TRT01A will be having the drugs like the daphnioquine and placebo, along with the overall of these two medication. Then we'll be seeing in the group will be having how many counts and what is the percentage of for and 86% for the group. So these are the groups we have to be represent in the output. So how many per protocol population? So for example, in the per protocol populations, how many? 39 of them are having tefnoquine, and 42 will be having the placebo, and 81 will be the all combining of these two. So each individual population it has divided. Okay, and we have given for safety population for one order, and ITT population will be 2, and randomization will be 3, and per protocol population will be having a 4. So once we done, and here, so these are the unique subject ID counts. Okay, so next we will be continuing doing that pivot table. So we're trying to transpose them. We're trying to transpose the safety populations, and these staff now placebo will become as a column wise on the top. So these are the count values will become below of this tefnoquine. Okay, so here we're using the summary dot pivot table by using the order and pop. Then columns will be the TRT01A. So here the column will become as a top, so we are considering TRT01A. Then values will be group, so for these values will come as the group column, and aggregation function will be the first, and reset index to reset the sequence. Then pivot columns dot name none. Okay, so we don't keep any extra. Okay, so the pivot columns dot names, so the basically we keep it as none, because in pandas when we're creating the pivot table, this gives some other names. So in order to we get our treatment related information, so we should have to avoid that columns are coming from the pandas library for the when we're doing the pivot table operation. So this is we keep it as none option. So here the next one is the pivot stat. Um, the stat column we are giving directly to the n percentage. So this is n percentage for stat column. So that is the one we have given here. Then the pivot equal to, and we're keeping as per the mock shell. So population first, then stat, then drug A, B, and 3. Okay, so this is we are giving as a 1, 2, 3, because we're giving as in that format. Then we have applying, then we are applying the columns, pivot dot columns, by giving that in order. Okay, so in the order we'll be having the first with order, then population, then we'll be having a statistics, then in the drug A, so we're giving as a basically we're giving as a label to them. So drug A slash n, n in the dictionary part, and one will be the n1 count will be in the dictionary part, and the f drug B slash n, the slash n, why it indicates this second row, this row has to go to the n equal to 43 in the bottom. Okay, for that reason we have to keep it like that. So let me run this one. Okay, so here if we check the pivot, so will be if we check the pivot data frame, now you see we'll be having drug N43, drug B, and all, and we will be having the counts along with the percentage, and this is the population flag, and we'll be having the order. So we got our final mock shell as per this we got final result as per this mock shell. Now we start doing that reporting part. Okay, in the reporting part what we're doing, we're just trying to using the document is in this format. Then we using the inches, the top margin, so in the bottom margin, left margin inches one we're giving as a width. Then we give it a style as a normal. So this is a basic template we when we are using how much points we required and what is the font name, and so this is a kind of giving that the template, the table look like in the reporting. So then we will be adding that add paragraph for doctorate add paragraph. Will be adding that the top here on the left side. So we'll be having this thing here, right? So we'll be adding those things. Then we'll also having the center part. So these are the left alignment, and we'll be having the center part that will be the center alignment. So subject assignment to analysis population, so this part. Okay, so just copy there and paste it there. Then what we're doing, we're doing the style. So we're giving the style light stating accent. Then remove padding in header. So we are trying to do some this is something more related to the template operations. So here, okay, so you're just trying to adjust that how much inches, how much width we needed as per this cell. So here also we are trying to check with header row and the data rows. We're doing the both of them here. Okay, so then we're giving as a footnote which will be the left side alignment. This is for only for general explanation purpose. In case in your mock shell, if you have other footnotes, you can copy that part and you will be pasted here. Okay, let me run. Okay, so once we done this part, then we have to save it to the final output, which will be the this is the path where it has to go and save it. So here this is the path, and here the table mock shell. Okay, so here we'll be having our counts and percentage. So maybe we can drop that order. Okay, maybe I can close this one first. Okay, I don't need order function, so we can remove that order from here. Okay, so here how many columns we'll be having? Okay, there is no column, so that is fine. Okay, so let me run this part. So if I go here, okay, so now we don't have order column. So here is the drug A and drug B and all. So there is a small margin. The length is not been clearly, the width is not been clearly mentioned for the both, but that is fine for the. So this is just for explanation. And usually in the real time we'll be having your own kind of template and the width, so you can adjust accordingly as per the mock shell. So these are the simple table analysis population. Hope you like it, and if you have any questions, please let me know. Thank you so much for listening.